different components. You got the graham cracker, you got the marshmallow, and you got the chocolate. And um, it's a lot like any other kind of synthesis reaction. Did you find them? Yeah. You get the case and everything? Yep. Nice. It's a lot like any synthesis reaction where you take individual chemicals and you react them together and you get one whole thing. So this exercise is very much like any other kind of synthesis reaction in a chemical equation. So it says s'more stoichiometry. So if you're going to make the s'mores, you got to have a graham cracker. So what we're going to do is treat the graham cracker like it's a diatomic element. Because you know when you buy graham crackers, it's like a rectangular thing and you can like crack it in the middle. You know what I'm talking about? So the top and the bottom of the graham cracker is actually one individual s'more thing in the sense that this graham cracker, and in this exercise, it's GC, like for graham cracker. So if you call GC like a graham cracker is like a diatomic in the sense that it's like GC2, but whenever you take that diatomic thing, you've got the full rectangular graham cracker and you crack it in half, you've got two individual like graham cracker atoms in the sense that this GC2 then lets you have the top and the bottom part of the s'more. The other components that we need are chocolate. So it might be like one little slab of chocolate, but there are three individual, like, Hershey's chocolate things. So you have three pieces of chocolate. So these are each chocolate. You got a chocolate here, and you got a chocolate there, and you got a chocolate here. And then you only need one marshmallow. I mean, you can have more marshmallow if you want, but you have a single marshmallow. So what we're trying to do is make this cookie out of the different components. So what you need are one of the graham cracker that is diatomic. You need one marshmallow, and you need three of the chocolates. And all together, that makes this graham cracker like GC2, marshmallow, and then chocolate with a three underneath it. Because although you have three individual pieces of chocolate, when it goes together as an individual s'more, there's only one of them, and the ingredients are two, like the graham cracker pieces, a marshmallow, and three pieces of chocolate. Now the deal is, in the lab, each of those things have different masses. So an individual graham cracker square, so just this one square of graham cracker, has a mass of 7 grams. Each piece of chocolate has a mass of 6.3 grams, and each marshmallow has a mass of 6.10 grams. So if you were to weigh out the amounts of ingredients you start with, how many total like graham crackers can you make? So if you were to buy like, a bunch of chocolate and a bunch of marshmallows and a box of graham crackers, it might be possible that as you're making s'mores, you've got the perfect number of graham crackers, marshmallows, and pieces of chocolate, and there's nothing left over. But what's more likely is that one of them is going to be the limiting reactant, in the sense that, like, let's say you don't know how s'mores really go together, and someone's like, hey, go to the store and buy the components for s'mores. You're going to need chocolate, graham crackers, and marshmallows. And so you buy, like, let's say you buy one chocolate bar, uh, one box of graham crackers, and one bag of marshmallows. Well, that one chocolate bar is not going to make you very many s'mores, but the box of graham crackers will make you a whole bunch of them, and the bag of marshmallows will make you a whole bunch of them. So the issue is that when you make the when you make the s'mores, you've got to have the correct proportion of the whole thing. So anyway, the total mass of a s'more, the GC2 MMCH3, that's the sum of the masses of all the components of the parts that go to make it up. So much like you might have a chemical, it doesn't matter. Like if you have calcium chloride, CaCl2, to figure out the mass of calcium chloride, you got one calcium and two chlorines. You multiply those by the formula masses, that gets you like total masses. Then you like add them up and you get a total. The same thing here, graham cracker, marshmallow, and the chocolate. If you add up the masses of the units of the parts that make them up, you get a total amount of mass. Anyway, so you can calculate the total mass of a s'more, and then if you have a bag of marshmallows with a mass of 152.5 grams, how many marshmallows must be in that bag? That would also determine how many s'mores you can end up making. If you want to use up all the marshmallows, how many graham crackers do you need? How many chocolate pieces do you need? And packages will never tell you how many like individual pieces there are, but you might know the total mass and the mass of the individual parts. So anyway, you should be able to figure out, based upon the quantities that are provided, which is the limiting reactant. Which of the things would you run out of first? Are you going to run out of the graham crackers first? Are you going to run out of the chocolate first? Are you going to run out of the marshmallows first? And how many cookies can you make in total? Hey, no, next period. Okay. Yeah, yeah, third period. Yep. Okay, let me show you what's going on. So if you're remote, um, let's see, Chem 1, on the right-hand side, oop, there's the so everybody, there's that stoichiometry maze worksheet. So if you were here yesterday and you turned it in, that's good. If you didn't, you can take a picture of it and you can include it there. The s'more stoichiometry is in the folder. Show you where that's at. 38311. That's the thing we're working on. I don't know what happened to it. I got to find it. So in just a minute or so, if you're remote, in just a couple minutes, it'll show up right here, this s'more stoichiometry activity. I got to find it in my, I don't know what happened to it. I'll put it here. So I'll just be back in just like a minute or two. Anyway, so if you didn't finish the stoichiometry maze thing, you can finish that and then work on the s'more stoichiometry. Once you get it all figured out, these aren't exactly s'mores cookies, but they're pretty banging. I don't know. Some use in other ways we end up making the s'mores in the class and weighing it out, but and figuring and measuring the individual masses, we're just not going to do that this year because of handling all the materials and stuff. We just decided not to do that. We just gave you masses for the individual parts, if that makes sense. But there's some of the banging marshmallow cookies. And if you're not quite sure if they're awesome, Ben can rep them. He's like, they're awesome. All these Benton's cookies. All right, cool. I gotta grab the file for the s'mores thing. I had it in an email. So, all right, cool. If you need to work together, you can work together at the lab table or whatever. To get that figured out. Yeah. Let's see. Your remote, just give me one more minute. I'll get that paper put in there and show you like best way to deal with it. Let's see. Misty.school. Okay, I got it done on the other computer. All right, anyway, so in the folder for this week of 3.8 to 3.11, there's a document, or there's a link here that says S'more Stoichiometry, complete the assignment and submit your work. So if you click on that, there's an individual Word document, and that should open within your browser, or I don't know exactly how it works on your Chromebook. It might download it. So anyway, it's a separate Word document, and you can write right in it. I mean, you got a choice of what you want to do, because sometimes like writing out math is a whole lot nicer and easier to do like by hand on paper than it is to type in, especially because if you're using a conversion factor. So anyway, you got this trying to make s'mores cookies. So there's 2 pieces of graham cracker, you've got the marshmallow, and 3 pieces of chocolate to go inside. So the total chemical equation, I wrote that on, let me switch to a different screen here. Yeah, so the equation is you got GC2 that represents that this graham cracker is diatomic. So the 2 pieces of graham cracker is actually one unit, a single marshmallow, and 3 pieces of chocolate. And together that makes, like in a synthesis reaction, this one s'more cookie that is composed of 2 pieces of graham cracker, a marshmallow, and 3 pieces of chocolate. So this is like the balanced chemical equation, because it has 2 graham crackers on each side, 2 GCs, 1 marshmallow on each side, and instead of 3 separate pieces of chocolate, those 3 pieces of chocolate are integrated together into the cookie, so it's CH3. But that equation is a balanced chemical equation. So then, get back to this other screen. There we go. You can figure out the total mass of a s'more the same way as you would figure out the total mass of a chemical compound. It's the mass of 2 graham crackers plus 1 marshmallow plus 3 pieces of chocolate. And the masses are here for each of the individual parts. You can record that in that space. So if it's easier to write these steps out on paper and take a picture and upload that, that's fine. If you want to type right in the document and then save it and upload it, that's okay too. If you have a printer and you want to print it out and write right in it, take a picture and upload that, that's fine. Any way is okay, as long as you can submit it in Schoology. So anyway, if you have a single bag of marshmallows, that's the total mass of marshmallows. How many marshmallows do you have in a bag? So if you know the mass of an individual marshmallow and the total mass of marshmallows in the bag, that'll let you know how many marshmallows you've got. How many cookies could you make if you had an unlimited amount of chocolate and graham cracker? If you wanted to use up all the marshmallows, how many graham crackers would you need, and how many chocolate pieces would you need if you're going to use up that whole bag of marshmallows? And then steps 5, 6, and 7 are similar applications about how many graham cracker or how many total s'mores cookies you could make with the different components: graham cracker, marshmallow, and chocolate. So it's very similar to, this is similar to a formula mass for a chemical compound, where maybe like you're making calcium chloride and calcium has a mass and chlorine has a mass. It just turns out that the masses of the graham cracker, marshmallow, and chocolate are very similar to each other. With chemical compounds, are usually, significantly different, because we go up in numbers of protons and neutrons on the periodic table. So anyway, that's the thing that I was trying to show you, but didn't have it in there. So now it's in there. I thought that I put it in there, but didn't. Yep.
So I'm assuming because it because graham cracker only appears as a diatomic, then like for instance for just number 4, but it gets like more in depth in the back. Like if you want to use all the marshmallows, how many graham crackers would you need? Does it want graham cracker halves or like a whole graham cracker?
Well, you can write it either way.
Okay.
So it's like you say, it's either 10 whole graham crackers or 20 of the pieces.
Okay.
Does that make sense?
Yeah.
That's the way diatomics are too. Like oxygen, we say oxygen, it's O2. But if you're going to make a compound that only needs one oxygen, that O2 gets broken up to make even more. You know what I'm talking about?
Yeah.
Yeah. Same deal.
Oh, it doesn't matter.
Yeah. Yep. I had it once. I haven't had it. Yeah, I think I don't. But you're definitely old. That's what old. Let's see, 25. Yeah. Yeah, looks good. It's cool. You good? If you want to turn it in, you can just go here. If you want a cookie, they're amazing. You good? You want to turn it in?
You have to have a check.
What's that?
You have to have a check. You know, if you want
Oh, I know what you mean. Yeah, I'll read it tonight though. Just put it in. And have a cookie. Let's see.